Welcome to the video solution of the CAT 23 slot 2 quant section. Now kindly understand that this paper was slightly on the difficult side, and hence in a normal paper, in case a good score could be attempting 10 to 12 question, on a difficult paper that number of question attempted could go down to 7 to 8 as well. So yes, the number of sitters are going to be slightly lower, and the time to, let's say, solve many of the question would be on the higher side. So because this particular paper was slightly more on algebra and one can say a moderate kind of arithmetic, but yes, again among the arithmetic also few of the questions were doable. So the task is to identify the easy one and, let's say, spend the time on the B question where you are very confident of arriving at the answer. So one need to gauge the pitch. So kindly understand that not every time a team can score a 400 plus score. It depends on the pitch to pitch. So in this particular case, again, the paper was slightly on the difficult side, and hence a lower marks can also fetch you a decent kind of percentile. In this sum, it is given that any non-zero real number x and y such that y is not equals to 3 and x upon y is less than x plus 3 upon y minus 3 will satisfy the condition. Now it's a question on inequality, and they've given you options like if this is more than 0, then so on like this. Now, few things which you need to be careful about in solving an inequality problem is that you tend to, let's say, sometime multiply some terms. And we know that if you multiply by some zero term which are going to be equals to 0, it's going to be a problem. At the same time, when you are multiplying a negative quantity on, let's say, both sides, in that particular case, the inequality changes. But if you multiply a term which happens to be, one can say, positive, in that case, the inequality remains unchanged. So most likely, if I want to simplify this inequality x upon y less than x plus 3 upon y minus 3, then ideally I want to multiply both sides by y and y minus 3. So in a way, I should know something about the values of y. And that is why I'm going to use the option in this particular case. And I'm going to possibly think about option number 1 and option number 2. So let's see, in option number 1, they are saying y is more than 10. In option number 2, y is less than 0. Now understand the situation, the term y and y minus 3. In the first case, if y is more than 10, then y is also positive. Then if y is more than 10, the term y minus 3 is also going to be positive. Both are positive. In case y is less than 0, then the term y would be negative, and the term y minus 3 is also going to be negative. So the required product of y and y minus 3 is going to be always a positive. So, and please note that this x and y are non-zero real number. Y is also not equals to 3. So none of the term y and y minus 3 can be equals to 0. So either both are positive or both are negative. So what I will do is I am multiplying the given inequality, which was x by y less than x plus 3 upon y minus 3, and I'm multiplying both sides by the quantity which is y into y minus 3. And please note, as I told you, the term y into y minus 3 is always positive. Plus into plus is plus. Minus into minus also happens to be a plus. So over here, if you look at now, we can cancel because y is non-zero, so we can cancel this y. And since I am multiplying by a positive quantity, I am not going to disturb this inequality. Over here, if you look at the term y minus 3 can also be cancelled because this is positive. The result basically is positive over here. And if you look at now, if I just open this bracket, one get xy minus 3x is less than, this will become xy plus a 3y. And if you look at over here, the term xy and xy can be easily cancelled, and one basically will get nothing but a minus 3x is less than 3y. So even this 3 and 3 can be cancelled. So one will get minus x is less than y. So please note, whether I take option number 1 or option number 2, the multiplication of y into y minus 3 happens to be positive. So in a way, option number 1 and 2 both can be checked with the same approach. And what we have seen, minus x is less than y, which happens to be true in this case and not in this particular case. And I can be very certain to mark option number 2 at this particular point. So if you look at the verdict about the difficulty of this particular question, not a very straightforward question, and there is a high chance of people making a lot of mistakes in this particular problem. And what you will notice in this particular case is that the accuracy can be slightly on the lower side. So again, this question won't be a type A, could be a B or could be a C, depending on how do you see a problem of inequality. The next sum which we have is let A, B, M and N be natural numbers such that A is more than 1, B is more than 1 and A power M into B power N happens to be equals to 144 raised to 145. Then the largest possible value of N minus M is. Again, a very deceptive question. Many of you will feel that they can crack this particular problem. The answer is yes, you can crack the problem. But the flip side would be many of you again are going to have a low accuracy in this particular question because of the way the options are being framed over here. So understand one thing, the target is to maximize the value of N minus M, which means this is possible. And please note all this variable A, B, M, N are nothing but natural number where A and B are both more than 1. So if I want N minus 1 to be largest, then N need to be, one can say, maximum, and minus M, then this should be nothing but minimum over here. So first thing which I want to do is, since I have A power M into B power N, the first thing is how to write the number 144. So 144, if you prime factorize, this number is nothing but 16 into 9. 16, one can say, is 2 power 4 into 9 happens to be a 3 square. So this number 144, first of all, I can write as 2 power 4 into a 3 square raised to a 145. And then this can be further written as 2 power. So understand A power M whole raised to N is equals to A power M into N. So the power of 2 would become 4 into 145, giving you a 580. And the power of 3 would become nothing but 3 raised to a 290. So at this particular point, most of us might say, okay, I want to take the value of N to be largest, M to be smallest. So maybe we can take this as the value of N as 580 and the value of M to be equals to a 290. Since A and M are both more than 1, so I can take this particular part as B and this particular part basically as A. So the issue would be the term N minus M will come out to be equals to 290, and most of us are going to see an option like 290 and we would be tempted to mark option number 2 over here, and that is where the problem basically would be. So it is perfectly fine to say that the largest possible value of, let's say, N is going to be a 180. But can the value of N be equals to 0? And the answer is no. So the answer definitely cannot be option number 4, because for 4, N we have got as 580 and the value of N in that particular case need to be equals to 0. We cannot take the value of N to be equals to 0 because they are saying A, B, M, N happens to be natural number. So in this particular scenario, if I want the value of M to be minimum, now understand the number 3 power 290 can be written like 3 power 145 whole square and so on. But can we also take the value of B? Can I take the value of B as 3 power 290 raised to 1? So I will take the value of B to be large so that the power M basically become as low as possible. And since I want the value of M to be natural number, the smallest possible value of M I can think about is nothing but equals to a 1. So minimum value of M will become equals to 1, and hence the largest possible difference between N minus M become nothing but equals to a 579, and this is my required answer and not option number 2 over here. In the next sum, it says that sum of all the possible values of x satisfying the equation 2 raised to 4x square is one term minus 2 raised to power is 2x square plus x plus 16. The third term is plus 2 power 2x plus 30 is equals to 0 is. Again, not a very straightforward problem in this particular case, and again we can have, let's say, two sort of method. One could be a proper conventional one. At the same time, we can think of some sort of logic to arrive at the answer. So let's look at what is going to be the logic. So maybe over here we can try to express this in the form of something like a square plus b square minus 2ab and so on like this. So if I look at the first term, and so basically the term which are basically positive, can both of them be written in the form of, one can say, something square, and the answer is yes. So if you look at this particular term 2 power 4x square, and we know this particular property, a raised to m whole raised to n is nothing but a raised to m into n. So here my first term I can rewrite as 2 raised to 2x square raised to 2. And that basically becomes 2 power 2x square into 2 is nothing but 4x square. The last term if you look at, which is plus 2 power 2x plus 30. So 2 power 2x plus 30 I can write as 2 power 2 common and x plus 15. And then I can write this particular part as 2 power x plus 15 whole square. So this will become 2 power x plus 15 whole square. Now, so we have got a square term, we have got a b square term, then we have a minus 2ab. So let's see, this is, let's say, some number a, this is some number b over here, and let's see what is the result 2ab. So if I want a 2ab term, let's see, do we have that power? So minus 2 power 1, a is 2 power 2x square. The term b in this particular case is 2 power x plus 15. So if I look at the central term in this particular case, we are basically multiplying 3 terms having the same base. And if I multiply 3 numbers with the same base, the power basically are going to be simply added. So if you add the number 1 plus 2x square plus x plus 15, we do get 2x square plus x plus 16. That means my term which is negative, minus of something, this particular part is also completely getting balanced. And what does that mean? That simply means that my left hand side is going to be of the form a square minus 2ab plus b square. So I can very much write this as a minus b whole square. So one can say 2 power 2x square minus 2 power x plus 15 whole square is equals to 0. And if I say a minus b whole square is 0, it simply means a minus b is equals to 0 or a is equals to b. So 2 power 2x square should be equals to 2 power x plus 15. So over here, for this scenario, the base are same. So in that particular case, the power must be equal. So 2x square should be equals to x plus 15. So we are getting a quadratic. So 2x square minus x minus 15 is equals to a 0. So now we have a quadratic in x, and the target is not to find out the value of x. The target is saying find the sum of all possible values of x. And here they are not talking about whether real values of x or imaginary. So if I have a quadratic, there should be 2 roots over here, and one can say the sum of the roots will be nothing but equals to a minus of b by a. So minus of b is minus 1, divide by a is 2. So this thing become equals to half. So sum of all possible values of x become equals to a 1 by 2. So one can choose to mark option number 4 over here. If I want to look at the jugaad way to solve this particular question, so what I will do is, I will take this term which is negative on the right hand side, and I can rewrite my given equation as 2 raised to 4x square plus 2 raised to 2x plus 30 is equals to a 2 power 2x square plus x plus 16 over here. Now, in this particular case, one thing you need to understand very carefully is that if I think about some scenario like 2 power 1 plus 2 square. So whenever, if I have adding 2 different powers of 2, this will never going to give me a quantity which will only be a power of 2. Because this is going to be 2 power 1 will be common, 1 plus 2 raised to 1. In case I make this particular part a 3, then let's say this is going to become 2 power 1 will be common, 1 plus 2 square. And again 1 plus 2 square will never going to be 2 power something. Then whether I take a 2 power 2 plus 2 power 4, then this thing will become 2 square will be common, and one get 1 plus 2 square. Again, this part can never become 2 power something. In simple word, if I have 2 power m plus 2 power n for m and n being distinct, in that particular case, this can never happen. So the only way it can happen is if I have suppose 2 power 2 plus 2 power 2, then one can say this is going to become 2 times of 2 power 2. And this thing is in the form of 2 power something. This will become 2 cube. Let's say if I have a 2 cube plus 2 cube, this thing is going to become nothing but 8 plus 8 is 16, or one can say 2 into 2 cube giving you 2 power 4. So one is going to observe this particular pattern, and one can say that this thing can only arise if one can say that these two terms are going to be equal. So if I equate them, 2 power 4x square is equals to 2 power 2x plus 30, then one can say 4x square is equals to a 2x plus 30. I can cancel entire thing by 2, giving you a 2x square is equals to x plus 15. If I bring everything on the left hand side, 2x square minus x minus 15 equals to 0. And again, once we get a quadratic, we have to find out the sum of all possible values of x. So the required sum of the root would be equals to minus of the coefficient of x, which is -1, upon the coefficient of x square, which is equals to a 2. And this thing very much become equals to a 1 by 2. The next sum which we have is again an interesting one, and I would say if people want to solve it in a conventional manner, this question is highly conceptual. It says that for any natural number m and n and k such that k divides both m plus 2n and let's say 3 plus 4n, then k must be a common divisor of. So understand one thing, k is a factor of m plus 2n. K is also a factor of the term 3m plus 4n over here. So understand if k divides m plus 2n, k is also going to divide every multiple. So 2 times of m plus 2n. So one can say k is going to be a factor of m plus 2n. If I double that, twice of this is also going to be 2m plus 4n. K also need to be a factor of, one can say, 3m plus 6n, 4m plus 8n, and so on like this. Similarly, they are saying k is also a factor of 3m plus 4n. So k is also going to be a factor of the multiples of 3m plus 4n, which is nothing but 6m plus 8n. Then one can say 9m plus 12n, and so on like this. Now, the objective in this particular case is k must be a factor, or one can say common divisor of this term and this term. So they have given you option only in terms of n and only in terms of n. So what I want to understand is that if I say k is a factor of a, k is also a factor of b, then k is also going to be a factor of a plus b. K is also going to be a factor of a minus b. This is the most important property which you need to be careful about. So here in this particular case, since I want only m or only a term involving n, in that particular case I am going to look for basically the term where m can be cancelled. So if I look at suppose this sequence over here, this terms over here, and if I look at the second line as well, do we see some term where m is same? So one can say I can find out this particular part. So if I look at over here, can I say k is a factor of 3m plus 6n? K is also a factor of 3m plus 4n. So if I say k is also going to be a factor of addition of this and at the same time difference of this two. So if you subtract 3m plus 6n and 3m plus 4n, one can say k is also going to be a factor or divisor of, one can say, a 2n. That's a certainty, going to be certainty. And at this particular point, one can say we get 2n only in one term. So one should think about marking option number 2 as the answer. But let's also think about m. In case I want for m, in that particular case, I will look for the term over here in the two sequences, let's say, or two series, where one can say n can be cancelled. So if you look at n, I can see 4n here and 4n here. So again, k is a factor of 3m plus 4n. K is also a factor of 2m plus 4n. So k is also going to be a factor of their sum and also the difference. So k is going to be a factor or divisor of this term minus this term. So 3m plus 4n minus 2m plus 4n, and this thing become equals to a 1. So k is a divisor of 2n, k is also a divisor of m over here, and that is why option number 2 is the right answer. In the next term, it says that for some positive real number x, if log of x to the base root 3 plus log of 25 to the base x divided by log of 0.008 base x is equals to 16 by 3, then find the value of log of 3x squared base 3 over here. So this question, I would say, is slightly on the simpler side. People who are comfortable with the formula of logarithm, they can easily crack this particular question. And maybe I would say people can solve this particular question under, maybe some of you will do it in 1 minute, some of you might take possibly 2 minutes also. But definitely in a tough paper like this is something which I would say you should be able to do it. So the first term, if you look at, is log of x base is root 3. I will keep it like this. Now the second term, if you look at, is again I will use the property log of a to the base b divided by log of c to the base b. So this base are same, and that's why it is going to be equals to a log of a upon log of c, or one can say log of a to the base c. So here, since this x is the common base and x is going to be a positive real number because the base cannot be negative or even equals to 1, this will be equals to, one can say, log 25 divided by log of 0.008 over here. Now, if I look at the number 25, I can think about 25 basically as 5 square. Now, what about the number 0.008? If I convert this in terms of fraction, I can say this is 8 upon 1000, which I would say is 1 upon 125. And this is, one can say 1 upon 5 cube, or one can say 5 power minus 3. This thing is equal to a 16 by 3. So log of x base root 3, this particular term, as I told you, log 25, I will write as log of 5 square. The term log of 0.008, I can write as log of 5 raised to a minus 3. And now we know that log of a power n is equals to n log a. So these powers are going to come in the front. So this 2 will come in the front. So 2 log 5. This would become a minus 3 log 5 in the denominator here, equal to a 16 by 3. So the second term, if you look at closely, become nothing but minus 2 by 3. So let's take that minus 2 by 3 on the right hand side. So will become 16 by 3 plus a 2 by 3 becomes, one can say, a 18 by 3, which is equals to a 6. So the value of x, one can say, is nothing but equals to, if log of a to the base b is equals to n, then a is equals to b power n. So the value of x would be equals to a root 3 raised to 6, which is 3 raised to half whole raised to 6, giving you a 3 cube. So we have got the value of x to be equals to 3 cube, and now we can easily find our question. It says log of 3x square base is 3. Now understand the term 3x square would be 3 into the term x square in this particular case would be 3 cube whole square, giving you a 3 power 6, base is 3. This will become 3 power 7, log of 3 power 7 base 3. And this thing would be written as 7 times of log 3 base 3. Log 3 base 3 is 1, so 7 into 1 gives you a 7. And the required answer for this particular question must be 7 over here. In the next sum, it says that let k be the largest integer such that the equation x minus 1 whole square plus 2kx plus 11 equals to 0 has no real root. If y is a positive real number, then the least possible value of k upon 4y plus 9y is how much? So first of all, let's take the help of the first statement where they are saying the given quadratic has no real root. Now understand that simply means that the roots are going to be imaginary, and for that to happen, the discriminant need to be less than 0. So first of all, in this particular case, what we need to do is we need to, let's say, open this particular term x minus 1 whole square. So we need to write the given quadratic in the form of ax square plus bx plus c. So we have some coefficient of x square, some coefficient of x, and the constant term. So if I expand this x minus 1 whole square, that will give you x square minus 2x plus 1 plus 2kx plus 11 equals to a 0. And this equation will now going to become x square. Then I can say plus 2x common, k minus 1 plus 12 equals to a 0. So in this particular case, we have got the quadratic in the form of ax square plus bx plus c, and since we don't have any real root, discriminant need to be less than 0. So one can say that delta need to be less than 0, which implies b square minus 4ac need to be less than 0, where a, b, c are the coefficient of x square, coefficient of x and constant term. A is 1 here, c is 12, and the term b is 2 into k minus 1. So one will get 2 into k minus 1 square minus 4ac, so 4 into 1 into 12 should be less than 0. So now we'll get 4 into k minus 1 whole square to be less than 48, or one can say the term k minus 1 square need to be less than 12 over here. Now please note that the nature of k is going to be a largest possible integer. So k need to be an integer. So in this particular case, which square one can say is less than 12? So one can say whether we have a 3 square or we have a minus 3 square, both will give you a 9, and 9 basically is less than the number 12. So if I want a 3 square term over here, one can say largest possible value of k as integer. So if I look at k integer, I can take most likely equals to a 4, because 4 minus 1 whole square will give you nothing but 3 square, and 3 square is less than 12. Again, if I want this part to become a minus 3, in that particular case, the lowest possible value of k as integer can be a minus 2. It cannot be a minus 3. So k being the largest integer, so I will take the value of k to be equals to a 4. And now the sum basically will become, basically if you look at this particular part, k is 4. So 4 upon 4y plus a 9y. So now the sum become, find out the least possible value of 1 by y plus 9y, where y is a positive real number. So many of the students will get stumped initially by looking at where does y come from in this particular case. But now if you look at, we are able to find out the largest integer value of k, which is equals to 4. And now the target is to minimize this. So in a way, if you look at the term y and 1 upon y are sort of reciprocal of each other. So we can think of applying, one can say am more than equals to gm inequality, which we have used multiple times. So one can say am more than equals to gm. So one can say the term 9y plus 1 by y divided by 2 need to be more than equals to square root of the product. So 9y into 1 by y. Root of 9 basically would be equals to a 3. So on cross multiplication, one will get 9y plus 1 by y would be more than equals to 2 into 3, giving you a 6. So the least value of 9y plus 1 by y and the term 9y plus 1 by y was nothing but k by 4y plus 9y. And this thing will become least equals to 6. And hence one can enter 6 as the answer for this particular question. In the next sum, it says that number of positive integer less than 50 having exactly two distinct factors other than 1 and the number itself. So it simply means that the number is going to have nothing but a total of 4 factors. So apart from 1 and the number itself, it has 2 distinct factors. So number n need to have 4 factors. Again, we know that if I have a number in the form of a power p into b power q, the number of factor formula is p plus 1 into q plus 1, which need to be equals to, one can say, nothing but a 4. So the number 4 I can write as 4 into 1 and 2 into 2. So if I take the case of 4 into 1 or a 2 into 2, one will say that this will lead to the value of p as 3, q as 0. That means my number can be of the form a cube. In this particular case, second case, the value of p would be 1, q would be 1. That means the number would be of the form a into a b. Please note a and b are nothing but the prime factors for the numbers. Now, again, this being a theta question, there could be a high chance of someone missing out on some numbers and so on. And please note, we have to concentrate on the positive integer which are less than 50. So first of all, if I look at the number of the form a cube, in that particular case, as I told you, a need to be a prime factor of the number. That means a need to be a prime number. So we can have 2 cube which is less than 50. We can have 3 cube which is less than 50. So we have two numbers of the form a cube which are below 50 and have exactly 4 factors. Now what about number of the form a into b? So understand, in this particular case, if I take the value of a as 2, then the largest possible value of b I can take is going to be, one can say, 24. So I will now look at that we can have 2 into 3. Then we can have a 2 into 5. We can go 2 into 7, 2 into 11, 2 into 13, 2 into 17, 2 into 19, 2 into 23. And this is less than 50. Then what about if I take the smallest possible a as 3, then 3 into 5. So if I have 3, then I can go max up to 16. So till 16 we can have 3 into 5, 3 into 7, 3 into 11, 3 into 13. That's it. We can't go to 3 into 17 because that is going to go above the number 50 mark. Then what about if I take 5? 5 into 7 is 35. 5 into 11 becomes 55. And if I start with 7 being the smallest prime factor, then 7 into 11 is going to be nothing but 77. That means we don't have any further cases. So the number of the form a into b, where 2 is the smallest prime factor, is 1, 2, 3, 4, 5, 6, 7, 8. 8 case for this. The number of the form a into b, where 3 is the smallest prime factor, happens to be 1, 2, 3, 4. And where 5 is the smallest, is nothing but a 1. So one can notice 8 plus 4 plus 1 becomes a 13. And we also have got two cases like 2 cube and 3 cube, giving you additional two numbers. And hence the required answer for this particular question would be 15 over here. Please note that you need to be very thorough with the concept of factors, because there is a high chance of someone missing out number of the form a cube, and you might not be able to count this particular two numbers. And since it's a theta scenario, you need to be very sure about your concept and the approach. In the next sum, it says that pipes A and C are fill pipes and pipe B is a drain pipe of a tank. Pipe B empties the full tank in 1 hour less than the time taken by pipe A to fill the empty tank. When pipes A, B and C are turned on together, the empty tank is filled in 2 hours. If the pipe B and C are turned on together when the tank is empty and the pipe B is turned off after 1 hour, then pipe C takes another 1 hour 15 minutes to fill the remaining tank. If the pipe A can fill the empty tank in less than 5 hours, then the time taken in minute by pipe C to fill the empty tank will be how much? So here we have 3 pipes, and we have also been given the comparison between the time taken by pipe B compared to pipe A. So we can reduce it to a 2 variable and not a 3 variable. So let's say if I talk about pipe A, pipe B, and let's say pipe C. And suppose if I say pipe A takes A hours to fill, in that particular case, pipe B will take A minus 1 hour to drain the entire full tank. And pipe C suppose takes C number of hours. Now in this particular case, pipe A and C are acting as a inlet pipe. They are filling the tank. At the same time, the pipe B is acting as an outlet pipe. So if I assume the work done by pipe A and C to be positive, I will assume the work done by the pipe B to be negative. Now, as per this particular portion, it is given that when A, B, C are turned on together, the empty tank is filled in 2 hours. That means if I look at the amount of work done in 1 hour by the pipe A, B and C together, is nothing but half. So in 1 hour, pipe A will do, one can say, 1 by A. In 1 hour, pipe C will fill a 1 by C. And in 1 hour, the pipe C will empty, one can say 1 upon A minus 1. And this should be equals to a 1 by 2, my first equation involving A and C. Then if I look at the next part, if pipe B and C are turned on together when the tank is empty and pipe B is turned off after 1 hour, that means pipe B has worked for 1 hour and must have drained out this much. And then C takes another 1 hour 15 minutes. So in simple word, one can say pipe C is working for 1 hour and then 1 hour 15 minutes, giving you a total span of 2 hour 15 minutes. That translates to 2 1 by 4 hour, or one can say 9 by 4 hours. So in 9 by 4 hour, one can say C will fill nothing but 9 by 4C. And in that particular case, the tank gets completely full. So this should be equals to a 1. So one can say we have two equations involving A and C, and over here people are most likely going to say I want to eliminate the term A minus 1, and they will possibly go into some sort of problem. Rather, suppose if I want to cancel out C, because we do have a condition regarding A as well, that the pipe A can fill the empty tank in less than 5 hours. That means the value of A need to be less than 5. So let's try to eliminate the value of C over here. So what I will do is I can, let's say, multiply my first equation by 9 by 4, and that will transfer my first equation as 9 by 4A minus 9 by 4 into A minus 1 plus 9 by 4C is equals to half of 9 by 4 will give me a 9 by 8. And then if I go for a subtraction, suppose if I call this, if I do 9 by 8 minus 1, this equation, bottom one minus the second one, in that particular case, the RHS part would become, one can say, a 1 by 8. The term C will get cancelled out. So one gets a 9 by 4A. And this is going to be equals to, if I call this as 4 into, this can be also 4. And this is going to become equals to, one can say, minus 5 upon 4 into A minus 1. And this thing is equals to a 1 by 8. So now I'm going to simply get a quadratic in A, and we can find out the value of A, and then we can possibly use this particular condition that the value of A need to be less than 5. So if I simplify this, if I take the LCM over here, LCM would be 4 into A minus 1. So one will get nothing but 9 into A minus 1, giving you a 9A minus 9, minus this particular part will become equals to a 5A, and this should be equals to a 1 by 8. So 9A minus 5A will become 4A. So this particular term will reduce to a 4A minus 9 in the numerator. Then if I simplify this 4 and this 8, so 2, let's cross multiply. One get A square minus A is equals to 8A minus 18. So now one will get A square minus 9A plus 18 equals to a 0. And now we can use formula, we can use middle term split, we can use completing perfect square, whatever you want to. This is going to become equals to A minus 3 into A minus 6 equals to 0. That means the value of A is coming out to be equals to a 3 or a 6. But please note that the value of A was less than 5. So this 6 can be discarded here. So I should take the value of A to be equals to 3. And we can put it in any of the equation. For example, if I take this equation, then one can say we had minus of 1 upon A minus 1, which become equals to a 2, plus 9 by 4C is equals to a 1. So 9 by 4C would become equals to 1 plus 1 by 2 will give me a 3 by 2. Then if I solve for this, the value of C become equals to a 3 by 2. Now this 3 by 2 happens to be in terms of R, so please don't mark 3 by 2. There's no option like 3 by 2 also over here. They want the answer in terms of minute, the time taken by pipe C to fill the empty tank. So 3 by 2R correspond to 3 by 2 of 60, giving you a 90 minute. And hence one can choose to mark option number 4 over here. In the next sum, if I read the problem, it says that Minu purchases a pair of sunglasses at ₹1,000 and sells to Kanu at 20% profit. Then Kanu sells it back to Minu at 20% loss. Finally, Minu sells the same pair of sunglasses to Tanu. If the total profit made by Minu from all her transaction happens to be ₹500, then the percentage of profit made by Minu when sold the pair of sunglasses to Tanu. So if you look at over here that Minu is, let's say, selling it to Kanu, and then Minu is also selling it to Tanu. So let's look at the two situation. First of all, Minu selling to Kanu, and finally Minu selling it to Tanu. So it is given that the cost basically was 1000 for Minu at the start for the pair of sunglasses. It was sold at a 20% profit. It means a profit of 200 received by Minu. That means it was sold to Kanu at, one can say, 1200. Now this same glasses was received again by Minu from Kanu. So Kanu to Minu. So something which was 1200 now was sold at a loss of 20% by Kanu to Minu. So it's a loss of 20%. That basically means nothing but, one can say, a 9 loss of 240, and that will bring the cost to a 960. So now Minu has purchased the sunglass again at 960, and the main thing is that overall Minu want to make a profit of 500. So understand, Minu already have made a profit of rupee 200 here. If I want an overall profit of 500 in all the transaction which Minu has done, obviously in selling, so here if you look at Minu selling it to Tanu, the profit should have been nothing but a 300, because I want a total of 500, out of which already we have made a profit of 200 by selling it to Kanu. So one can say 300 profit need to be made on a cost of 960, and that is what my answer should be. So a profit of 300, because end objective was percentage of profit made by Minu when she sold the pair of sunglasses to Tanu. So a profit of 300 on something which is 960 into 100. Then this can be easily cancelled out. Then 6 into 5, this is 16. So one can say 5 by 16, 1 upon 16, one can say is equals to a 6.25. So the number 5 upon 16 translates to a 31.25%. And hence one can mark option number 4 over here. So if you look at, once you complete this particular question, the numbers also are simple, and this particular question is definitely going to be a category. In this difficult paper, you can't, let's say, let go of this kinds of problem. In the next sum, it says that Ravi is driving at a speed of 40 kmph on road. Vijay is 54 meters behind Ravi and driving in the same direction as Ravi. One more person, Ashok, is driving along the same road from the opposite direction at a speed of 50 kmph and is 225 meters away from Ravi. The speed in kmph at which Vijay should drive so that all the three cross each other at the same time. This is a very, very important point, that all three are crossing at the same time. So in this particular scenario, what we can do is, first of all, make a rough diagram. So this sum looks slightly simpler. So if I just make a line, and suppose if I say this guy is Ravi traveling at the speed of 40 kmph, and let's say Ravi is going in this direction. The person Vijay seems to be also traveling in the same direction. We don't know the speed of the person Vijay, and the gap between Vijay and Ravi seems to be 54 meters. Then the person Ashok, who is traveling in the opposite direction. So let's say we have the person Ashok over here traveling at the speed of 50 kmph and moving, let's say, towards Ravi. So what we can do in this particular case is that the time taken by, let's say, Vijay to overtake Ravi or meet Ravi will be exactly same as time taken by Ashok to meet the person Ravi. In short, all three are meeting at the same point. So what is constant? The main thing is time is going to be constant over here. And what is time? So time is equals to nothing but distance divided by speed. I can say in this particular case the term relative speed. So I will just equate the time for both the scenario. So if you look at the person Vijay need to have more speed than the number 40 over here. So in this particular context, the distance is 54 meters. Now one need to be slightly careful, because the speeds are given to you in terms of kmph. The answer they want also need to be in terms of kmph. The distance given to you is in terms of, let's say, meters. But fine, you will see that it's not going to matter. So it's a 54 over here. And if I assume the speed of, let's say, Vijay to be some number x over here, and since they are traveling in the same direction, the speed become, one can say, x minus 40. This is in kmph. If I want to write this in terms of meter per second, this same speed need to be multiplied by 5 by 18. Now, what about the time, let's say for Ashok to meet Ravi? The gap between Ashok and Ravi is given to you as 225 meters. So, time taken would be a 225 meter distance. And if I look at the relative speed, since Ashok and Ravi are traveling in the opposite direction, the relative speed becomes nothing but one can say sum of the two speed, 50 plus 40 will give you a 90. This is 90 kmph. If I want to convert in terms of meter per second, I need to multiply here by 5 by 18. Now, since the two times are equal, and my task is to find out the value of x, you can notice one simple thing, the term 5 by 18 can be easily cancelled out and not playing a crucial role for finding out the value of x. Please note, if I want the value of, let's say, time, then definitely 5 by 18 will play a role over here. So now we can simply say that this particular part we need to calculate. So x minus 40 into 225 need to be equals to a 90 into a 54. And now at this particular point, we have to do some sort of calculation. The number 225 and the number 90 I can possibly cancel by 15 first of all. This is 15 15s. This is 15 6s. Then we can also further reduce this number, let's say by cancelling it by possibly a 3. 3 into 5. This is 3 into 2. So what do we have? We have got the value of x minus 40 to be equals to 2 into 54 over here becomes a 108. 108 upon 5. So 108 upon 5 become equals to a 21.6. And that means the value of x in this particular case would be 40 plus 21.6, giving you a 61.6 kmph. And that is my speed of the person Vijay, and that is what has been asked, and hence one can mark option number 3 over here. In the next sum, it is given that in a company, 20% of the employee work in the manufacturing department. If the total salary obtained by all the manufacturing employee is 1/6 of the total salary obtained by all the employee in the company, then the ratio of the average salary obtained by the manufacturing employee to the average salary obtained by the non-manufacturing employee is how much? So in this particular case, if you look at, they have not given the number of people. They have also not given the total amount given to the employee. That means we can definitely assume some convenient number. So what I will do is I will write two scenarios. One is the manufacturing department and maybe the non-manufacturing department. And we are going to focus on a couple of components. One is about the number of employees. So the number of employees. So if you look at over here, the first line says 20% of the employee work in the manufacturing department. This 20% means 1 by 5. So if the total number of people, let's say, are 5, then one can say out of 5, 1 is in the manufacturing. So one can say, what about the number of people in the non-manufacturing? One can simply say will be equals to a 4. So we have taken the use of the first sentence. What about the second one? Second one talks about the total salary obtained by all the manufacturing employees is 1/6 of the total salary by all the employee in the company. So if I look at the total salary, so the amount received by the manufacturing employee is 1/6 of this particular number. So what we can do is we can take this particular number to be some multiple of 6. For the convenience purpose, we can take this number as 600, we can take it as 60 and whatnot. Suppose if I take this particular number as 60 over here, then in that particular case, this particular part, total amount received by the manufacturing person happens to be nothing but 1/6 of this number, giving you a 10. That means the salary received by the non-manufacturing one become nothing but equals to remaining, which is 50. So now what they're saying is the ratio of the average salary obtained by the manufacturing employee to the average salary obtained by the non-manufacturing one. Now, what is the concept of average salary? Nothing but total salary received by the manufacturing employee divided by the number of employee. So 10 divided by 1 is 10 and 50 divided by 4 And the task is to find out the ratio of these two numbers. So if you look at over here, 0 and 0 can be cancelled. If you simplify 1 is to 5 by 4, that will become nothing but 4 is to 5. And hence, since I want them in the order manufacturing to non-manufacturing, I should choose to mark 4 is to 5, which is option number 1 over here. Again, a straightforward question which I would put under a category A over here. Now, those of you who are scared with this number fraction over here, in that particular case, I could also take this particular amount as 600. In that particular case, the total salary received by the manufacturing employee would be 1/6 of this number, giving you 100. And that means the other department becomes 500. So now it is going to be easy. A rupee 100 being shared, let's say, by one employee, average becomes 100. Non-manufacturing, 4 people receiving a 500 becoming, one can say, a 125 on an average. And now one can take the ratio of 100 and 125. I can cancel both this number by 25, 25 into 4, 25 into 5. So the required ratio has to be 4 is to 5, which is my option number 1 over here. In the next sum, it is given that Anil borrows rupee 2 lakh at an interest rate of 8% per annum, compounded half yearly. That means for each period of 6 months, the rate basically would be nothing but effectively a 4%. So one can say 4% for every 6 months. He repays rupee 10,320 at the end of the first year and closes the loan by paying the outstanding amount at the end of the third year. Then the total interest in rupee paid over the 3 years is nearest to how much? So in this particular case, what we need to first of all understand is that this particular formula, that amount at the end of n year is equals to principal into 1 plus r% raised to n. In case I talk about the interest is being compounded yearly. But if I have interest being compounded half yearly, this particular part becomes r by 2 and this thing becomes equals to a 2n. So here the value of r is 8. So this particular term would become nothing but a 4%. So let's try to find out what is happening, how much is the amount or what is the interest component, one can say, at the end of the first year. So the amount taken is basically rupee 2 lakh. That's my principal. Now at the end of the first year, the interest due, so one can say first of all amount at the end of first year would be equals to 2 lakh into 1.04, because effective rate is 4% over a 2 period. So 1.04 square will be 2 lakh into 1.0816. So if someone know how to find 104 square using the speed math technique, this number should be very, very familiar. So one can say here that the effective interest component, so interest due, interest at the end of first year before we made any payment will be nothing but 8.16%. 8.16% of the number 2 lakh over here, and this thing will come out to be nothing but as 16320, 16,320. And out of that, I already have paid an amount of 10320. So minus 10320. That means the correct interest amount which is due is nothing but 6,000. So my overall due amount is nothing but 2 lakh plus this 6,000 at the end of the first year after my first payment of 10320. So the amount or the amount due at the end of the first year after the payment becomes 206,000. And then what is happening is the entire outstanding amount basically is going to be paid at the end of the third year. So from the first year to the third year, the amount due would be nothing but 1.04 raised to, since we have a 2-year period now from first to the third, it will be 1.04 raised to a 4. Now again, this is going to be slightly on the difficult side, definitely a question where you should want to use the help of calculator. Again, because they are saying over here nearest to, so we can take the liberty of doing some sort of approximation. We know that a 4% and a 4% using subsequent or successive percentage increase. So one could also have done 4% and 4% 2 times. So 4 plus 4 plus 4 into 4 upon 100 will give you a 8.16%. And with the help of that, we have found out that number of, one can say, 16,320. Now, In this particular case, one can say 4%, 4%, 4%, and 4%. So we have seen in 1 year 8.16, in the next year 8.16. So basically 8.16 being compounded 2 times, 8.16 plus 8.16 plus 8.16 into 8.16 divided by 100. This part becomes roughly a 16.32. 8, if I assume also this to be 8 into 8, so it becomes a 64. 64 upon 100 becomes a 0.64. And that means we are getting nothing but a roughly close to, one can say 16.96. So we can take this particular part, the interest component become another 17%. So I can find out the interest component right now to be 17%. So it will be 17% of 2,06,000. So in this particular case, 1% correspond to 2060 into the number 17. Let's try to evaluate this number. This will be a 0. 17 into 6 is, this is going to become a 35020. So the total amount paid at the end of the third year is nothing but 206,000 plus this 35020, and that one can say becomes 241,020. And please note that you also have paid something at the start, which is nothing but an amount of 10320. So 10320, if I add them up, this become, one can say, close to a 4. This total amount paid when I paid the first tranche at the end of first year and amount at the end of third year become, one can say, this is 40. This is going to be a 340, and then this becomes a 251. So please note the loan taken basically was of 2 lakh, and effectively I have paid, one can say, 251,340. So the total interest paid over the 3 years is nothing but, one can say, 51,340. And with the help of the option given to you, one can clearly mark option number 1 as the answer. Please note, people can also make a mistake over here by simply saying 35020 plus this number 10320. But please note the interest due at the end of the first year was 16,320. So one could do 16,320 and you could add the number 35020. Both will lead to nothing but 51340. And since they have told nearest to and the options are spread out, we can take the liberty to mark option number 1 as the answer over here. In the next sum, it says that the price of a precious stone is directly proportional to the square of the weight. So price is proportional to the square of the weight. If Sita has a precious stone weighing 18 unit, she breaks into 4 pieces with each piece having a distinct integer. So please note the word distinct is important. At the same time, the word integer is also going to be important. Then the difference between the highest and the lowest possible value of the total prices of the 4 pieces will be nothing but, one can say, 2,88,000. And the price of the original precious stone is how much? So first of all, you need to understand when the price is going to be the highest. In that particular case, you need to have, let's say, one piece having the largest possible weight, and that can only happen if I take the other 3 to be as low as possible. When will I get the lowest possible value of the precious stone? In that particular case, one can say that you have to take the 4 weights which are going to be as close as possible. Again, for the sake of convenience, what we can do in this particular case is you can take an example. Let's say we have a stone of, let's say, weight 4 gram, let's say, or whatever, 4 units. If I split them, let's say, as 1 and 3, in that particular case, the price will be nothing but 1 plus 9 giving you a 10. 1 square plus 3 square giving you a 10. What about if I have taken them as 2 and 2? Please note, yes, they have told distinct, but suppose even if I take them as 2 and a 2, in that particular case, 2 square plus 2 square will give me nothing but a 4 over here, 8 over here. And we are getting smaller value. So as we understood, in case I want the max possible value of the stone, in that particular case, I should take the 4 weights where one of them is going to be highest, other 3 are going to be lowest. And since I want them to be distinct, what I can say is that we can have weight like, suppose if I call W1, W2, W3 and W4. And if I want the scenario for maximum, So first of all, I am focusing on the maximum part. So as I told you, let's take W1, W2, W3 to be nothing but 1, 2 and 3. It has to be integer, it has to be distinct, and if I want 3 of them to be smallest, it has to be 1, 2 and 3. How much is remaining? One can say 12. That should go over here. So if the weight is 1, then the corresponding price would be nothing but square of the number. So 1 square gives you a 1, 2 square gives you a 4, 3 square gives you a 9, and 12 square gives you a 144. And this total become equals to a 158, let's say, or 150x you can say, or 150x square also over here. Because when I say P is proportional to W square, basically P is equals to some constant into 8 square. But that is not going to be important, we can deal with that. If I take the scenario of the minimum, as I told you, in the ideal case, I wanted this 18 to be divided equally. So it could be 4.5, 4.5 is my average. So 4.5, 4.5, 4.5. But since I want distinct and I also want the numbers weights to be integer, in that particular case, I can make this particular part 5 by increasing it by 0.5. So I can decrease this number by 0.5. So I can make this number as 4 and this number as 5. The number have to be distinct. Then I can make this particular number to be 6 by increasing it by 1.5. At the same time, this can be reduced by 1.5. So as total remains 18, this would become a 3. This would become a 6. And the corresponding price, these are the weights, would be 3 square, 9, 16, 25 and 36. So total one can say become nothing but a 9 plus 16 is 25, 25 plus 25 becomes a 50, 50 plus 36 become equals to 86. So as I told you, you can say the price will be nothing but something square here. What is the difference? If you look at the difference in this particular case, this amounts to a 72. The thing is that 158 minus 86 is nothing but 72. If I say 72 parts is my difference between the max possible value of those stones, then this is given to you as 288000. So one part will be nothing but one can say 4000 over here, because 288 upon 72 will give me a 4. I got one part correspond to 4000. In that particular case, price of the original stone. So please note the original one has a weight of 18. So the price one can say is proportional to, one can say 18 square, which is 324. So I just need to answer now, if one part correspond to a 4000, then 324 parts correspond to how much? So it must be 324 into a 4000. So 4 into 4 is 16, carry 1. 32 into 4 is 128. 128 plus 1 becomes a 129. So 1296000, and hence option number 1 is the required answer for this particular question. In the next sum, it is given that Jayan bought a certain number of white shirt at the rate of rupee 1000 per piece and certain number of blue shirt at the rate of rupee 1125 per piece. For each shirt, he then set a fixed market price which was 25% higher than the average cost of all the shirt. He sold all the shirt at a discount of 10% and made a total profit of rupee 51,000. If he bought both color of shirts, then the maximum possible total number of shirt that he could have bought is how much? So in this particular case, again, a theta question, the objective is to maximize. So it's not a very, very straightforward problem. People who are good with algebra will find this particular question to be slightly on the easier side, even though it is a arithmetic question, but you have to use some sort of variable, again using a max or a min concept. So here, suppose if I first of all assume that we have purchased X number of white shirt and let's say Y number of blue shirt, and please note, if we bought both color of shirt, that means the value of X and Y need to be a natural number. It cannot be 0 also. So in this particular scenario, first of all, your total cost, if I look at the total cost, will be nothing but 1000 is the price of one white shirt, so 1000 times of X, and the total cost of, let's say, the blue shirt would be nothing but 1125Y. So 1000X plus 1125Y become nothing but my total cost. Now what is happening? Obviously, if you look at the price which has been set, it is 25% higher. So understand, if I talk about the whatever total cost, or you can say average cost, whatever cost you have, then you are increasing it by 25%. That basically become nothing but one can say 1.25 times. And after that, you are giving a discount of 10%. That becomes a 0.9 over here. So if you do this particular calculation, you will find that this thing will come out to be nothing but I can write the number 1.25 as 125 by 100, or one can say 5 by 4. This thing I can write basically as 9 by 10. So this thing basically become equals to a 9 by 8. And what does a 9 by 8 indicate? One can say nothing but 112.5. That means my effective profit per, let's say, per item or total item is nothing but in percentage term made a profit of 12.5%. That is my profit. Now, another way to arrive at the same number 12.5 would be that you are increasing the price by 25% and then giving a discount of 10%. So again, we can use the concept of successive percentage changes. So we can use that formula A plus B plus AB upon 100. So an increase of 25, then a drop of 10, then 25 into minus 10 upon 100. This becomes a 15 minus 2.5, giving you a 12.5% profit. So understand, my total cost is 1000x plus 1125y, and we made a profit of 51,000 in total. So if I look at in terms of variable, I can say my profit has to be nothing but 12.5%, or one can say 1/8. That is my total profit. So that is what we will equate. 1/8 of the number 1000x plus 1125y should be equals to, one can say, the number which is 51,000. Now at this particular point, what we can say is that ideally, if you wanted the max possible number of shirt and we have made a profit of 51,000, your value of x should be high and the value of, let's say, y need to be as low as possible. But fine, suppose if I just cross multiply by 8 first of all, so one gets a 1000x plus 1125y is equals to 51 into 8 is 408,000. So now please note, the target for you is to maximize x plus y. This need to be maximum. Again, we have different ways in which you can solve this particular question. What I will do in this particular case is I am just going to first of all write this as 1000x plus 1000y, another 125y is equals to 408,000. If I take this particular term on the right hand side, then one can say this will be 1000x plus 1000y is equals to 408,000 minus a 125y. We can take 1000 common, and then if I divide by 1000 throughout, one will get x plus y is going to be equals to, if I divide by 1000, one get nothing but 408 here minus 125y by 1000. 125 into 8 is 1000. So we get x plus y to be equals to 408 minus a y by 8. So the thing is, if I wanted the value of x plus y to be maximum, in that case 408 minus this particular term should be minimum. And please note, the value of y need to be this particular part should also be an integer, and this y need to be a natural number. So if I want this particular part to be integer, the value of y need to be a multiple of 8, and as a natural number, the minimum value of y I can take would be nothing but equals to 8. And that will give you 408 minus 1, which is equals to a 407. And hence the answer for this particular question would be a 407. Please note, this is not a very straightforward problem. Many of you will find out the average cost and then multiply by x plus y, and you will do lot many things. And effectively, this is not a straightforward question. I would put them under bracket of type B or possibly a type C for someone who is not comfortable of solving arithmetic using algebra. In this particular sum, it is given that if a certain amount of money you divide equally among n person, each one receives a 352. So if I look at suppose the first line, what we can think is, if I have n number of people, each getting a 352. So total amount or total money involved is nothing but 352 into a n over here, because total is equals to average into the number of term. Now they are saying if two people receive 506 each, so out of let's say 352n, you are already giving what? One can say a 506 to two people. So you're subtracting basically 1012. So the remaining amount, one can say, would be nothing but 352n minus 1012. And if I divide this equally among the remaining persons, so out of n, two of them have got a 506 each. So remaining one can say is nothing but n minus 2 people. And this average, they are saying each one receive less than or equals to a 330. So this quantity must be less than or equals to a 330. Let's cross multiply. So one get 352n minus 1012 less than equals to, if I cross multiply, one get 330n minus a 660. If I bring n on one side, so 352n minus 330n will give me a 22n less than equals to 1012 minus a 660. So 22n is less than equals to this particular part become equals to a 352. If you solve for this, n would be less than equals to, so 22 ones are 22, 132 is left, 22 into 6 happens to be a 132. So n is less than equals to 16, and the task is to maximize the value of n. So if I say n is less than equal to 16, the largest value of n one can take would be equal to 16, and that is my answer for this particular question. So if someone look at the approach for this particular question, you need to be good in the concept of averages, and one can see that if someone proceed with the required condition, this is not going to be a very difficult question. So I'm going to put this under a A or a B, again B for someone who is not comfortable with the concept of averages. Now in this particular case, we can also possibly see that it is going to be a scenario of using an allegation concept. So if you look at overall, the average need to be a 352. The two people are receiving a 506. So for these two people, the average amount received is a 506. The remaining n minus 2 people, they can receive maximum, one can say a 330, not beyond that. So if I look at suppose this part, this will give you a 506 minus a 352 will give me a 154 here. And this thing will come out to be equals to, one can say, 22. So the required ratio one can see in this particular case happens to be nothing but a 1:7. So if I have 1:7, then for 2, this particular number must correspond to, one can say, 14. So if I have two people receiving 506 each, then one can say the remaining 14 people have received a 330 each. So if I want to maximize the value of n, this number should be, one can say, as large as possible, because you want this particular number to be smaller. So this will basically would make nothing but 2 plus 14 giving you a total of 16 people, and that is what the answer would be for this particular question. In the next one, it says that the container has 40 liters of milk. Then 4 liters are removed from the container and replaced with 4 liters of water. So again, look like a very standard questions of replacement under averages and mixtures. This process of replacing 4 liters of the liquid in the container with an equal amount of water is continued repeatedly. The smallest number of time of doing this process, after which the volume of the milk in the container become less than that of water. In other words, basically I want a situation where the concentration of the milk become basically less than, one can say, 50%. Because if I have 50% of milk and 50% of water, then milk is equals to water. But moment suppose the concentration of the milk become less than 50%, you have more water than the milk scenario. So in this particular case, we can use the concept of wine replacement formula. So if I look at what part is getting removed every time, 4 liter. So one can say it is going to be nothing but, and 4 correspond to what? Nothing but, one can say, 40. Out of that, you're removing a 4 out of 40. This, if I do it n number of time, I want this to fall below less than 50%, or one can say below 0.5. So this thing, if you look at 36 upon 40, one can say nothing but a 0.9. You could also have got from this, because every time 10% is getting replaced, remaining is 90% or a 0.9. This is using the Wine left formula, which has been done in the concept videos. So one gets a 0.9 raised to n to be less than a 0.5 over here. So now if you put n equals to 1, n equals to 2, so n equals to 1 will give me a 0.9, n equals to 2 will give me a 0.81, then a 0.729, then a 0.6561. So at this particular moment we have done, let's say for n equals to 1, n equals to 2, n equals to 3, n equals to 4, and so on. And every time one can say 10% basically is going to reduce. So if I also go for n equals to 5, and in this particular case if I subtract, let's say approximately 6.5, this would come out to be, one can say, close to 59%. Again, this 59, again this is approximately, people can take the help of calculator for such a problem. You keep on doing 0.9, let's say, and see wherever you get the number to be less than a 0.5. If I do it for one more time, from 59, suppose if I subtract again 10%, so 59 minus 5.9, even if I assume a 6 over here, this will go to close to 53. And then if I do n equals to a 7 over here, from 53, a drop of 10%, so 53 minus 5.3 will come out to be nothing but close to a 48%. And that means it is coming down below a 48% mark. You can take this as in terms of percentage. This could be a 0.59. These are in terms of percentage. This is close to 0.59, 0.53, 0.48. So it is coming down below 50% after doing 7 iteration. And hence, the smallest number of times this need to be performed happen to be nothing but n equals to a 7 over here. And that is the answer for this particular question. In the next sum, it is given that a triangle is drawn with the vertices on the circle such that one of its side is the diameter of C. The other two sides have their length in the ratio of A is to B. If the radius of the circle happens to be R, then the area of the triangle is how much? So again, let's construct a circle, rough circle. And one of the side of the triangle happens to be the diameter. Suppose if I call this as A, B, and this is, let's say, C. So please note all the three vertex need to be on the circle. So now since AB is the diameter, and suppose if I call this OB the radius, center of the circle, then this angle ACB has to be a 90 degrees since AB is the diameter. Angle in a semicircle happens to be at right angle. And they are saying the ratio happens to be A is to B and so on like this. Task is to find out the area of the triangle. So this is, and please note they have not given any value as such. So if I assume this OA is R, OB is R, this if I suppose take as AK and this as BK, because they have told the ratio being A is to B. So I'm assuming my two sides as AK and BK over here. So if I try to apply first of all the Pythagoras theorem, so one can say you will get AK whole square plus BK whole square is equals to the diameter square, which is 2R square. So we are getting right now, one can say K square, I can take common, times A square plus B square to be equals to a 4R square. So we have got one sort of relation between, one can say, A, R and K over here. What is the objective? Objective for us is to find out how much is the area for this particular triangle. So area of the triangle ACB, if you look at, one can say would be equals to a half of base into height. So I can take the two perpendicular side, one as base, other being the height. So it must be AK into a BK. And this thing would be nothing but equals to A into B into K square. Now please note everything in the options are given to you in terms of A, B and R. So what I can do is I can simply put the value of K square. So the term K square, if you look at from this, will be equals to 4R square upon A square plus a B square. And if you do this, this will become 2ABR square upon A square plus B square. And that basically means my required answer for this particular question must be option number 4 over here. Now, those who found, let's say, the previous question to be slightly difficult because it involves the variables a, b, and r, since they want the answer in terms of a, b, and r, we can also take some suitable values of a, b, and r as well. So in this particular case, suppose if I take the value of r to be equals to 5, so the diameter become equals to a 10. This is, let's say, b, or one can say a, b, this is c, let's say, whatever. And this being a right angle triangle. So in right angle triangle, if I have taken one of the hypotenuse to be equals to a 10, I can take the other two values to be like 6 and 8. Because 6, 8, 10 becomes a right angle triangle. 3, 4, 5 is the first known Pythagorean triplet. So I can take 6, 8, 10 for the sake of convenience. So here a is 6, let's say. B is equals to a 8 and the value of r is equals to a 5. Now, if I look at the option, I can simply put the values of a, b, and r in all the options. Now, one thing, if you look at the term a, b, r square and a square plus b square in the denominator, this part basically is constant. What is happening is in option number 1, we are just multiplying that by half. In the second one, there is no change. In the third one, we are multiplying it by 4. In the fourth one, we are multiplying it by 2. So what we can do is, objective is to find out the area of the triangle. So one can say the required area in this case must be equals to half of 6 into 8. That will give you nothing but a 24. So what I want is, which particular option will give you a 24? Before that, I want to first of all evaluate the term a into b into r square. So 6 into 8 into 5 square, which is 25, divide by a square plus b square, which happens to be nothing but equals to, one can say, 100. This is 4, this is 2. So right now, this thing is coming out to be a 12. If I want to go to a 24 from the number 12, this thing need to be multiplied by 2 on both sides. And that will give you 24. And I want the required area of the triangle to be equals to a 24. And hence, my required answer for this particular question must be option number 4 over here. In the next sum, it says that in the rectangle ABCD, AB is equals to 9 cm, BC is equals to 6 cm. P and Q are the 2 points on BC such that the area of the figures. So they have given you area of the figure ABP. So triangle ABP, triangle APQ, and then one can say the quadrilateral AQCD are in a geometric progression. If the area of the figure AQCD is 4 times the area of the triangle ABP. So here, if I take this particular point, that if area of the APB triangle is 1, in that particular case, area of the AQCD triangle has to be nothing but equals to a 4. Which would mean if I want this 3 term to be in GP, this has to be in a geometric progression. So 1, 2, 4 is what this should be. So for this particular question, you don't need to take that 9 and 6 into consideration. What I can do is, suppose if I construct a rectangle, let's say like this, A, B, C, D, then we have the points P and Q on this BC such that area of the triangle ABP, APQ, and the remaining one AQCD is nothing but, one can say, in the ratio of 1:2:4. So if I have taken this particular area as 1, then APQ will become a 2 and AQCD will become equals to a 4. And hence one can look at the entire area of the rectangle in this particular case happens to be nothing but equals to a 7. 4 plus 2 plus 1 becomes a 7. So now, if you look at, if I join this AC, then one can say AC is nothing but the diagonal, and the diagonal AC will divide the triangle into 2 equal areas. So over here, my area ABCD is equals to a 7. That means the area of the triangle ABC will become equals to a 3.5, which would mean that this particular portion ACD will be 3.5 and this is going to be equals to a 0.5. If I want to avoid this 0.5, one could have doubled the numbers 2, 4 and 8 as well. But this is what we get. And now if you look at, the objective is to find out the ratio of BP is to PQ is to a QC. So if I focus on the triangle ABP, triangle APQ, and the triangle AQC over here, what I can notice is that for each of this triangle, the height is nothing but same. AB, one can say, or CD, AB is the height for ABP, also for APQ triangle, and also for AQC triangle. So if I know the ratio of the area for ABP, APQ, and AQC are in the ratio of, one can say, 1 is to 2 is to a 0.5, and this ratio of the area has to be nothing but in the ratio of their base as height is same. Please note the area of a triangle is equals to half of base into height. So the ratio of 1 is to 2 is to 0.5, which I can simplify as 2 is to 4 is to 1, is also going to be the ratio of, one can say, the base, which is BP, PQ, and QC. So my ratio of BP, PQ, and QC will be in the ratio of 2 is to 4 is to 1, and hence one can choose to mark option number 1 as the answer. In the next sum, it says that find the area of the quadrilateral bounded by the y-axis, the line x equals to 5, and the lines mod of x minus y minus mod of x minus 5 is equals to a 2. Again, a theta question, and I would say this is definitely going to be a C category of question. This is not a straightforward problem. One need to, let's say, look at the proper graph. So only those people who are very good with graph can possibly solve this particular question. Even those people will find this particular sum to be on the difficult side. My rating would be type C. This should have been left under the exam condition. But let's look at what would be the approach to solve this particular question. So first of all, we have the y-axis and the x equals to 5. That means y-axis, one can say, correspond to x equals to a 0, and x equals to 5, one can say, is a vertical line. So first of all, I am only concerned between x equals to 0 and x equals to 5 over here. So we will look at, suppose, a portion like this, maybe line like this, somewhat like this. But we are only interested in the region between x equals to 0 and 5. Now, so I'm not concerned about how the graph might look like beyond x, which is more than 5, or is x less than 0. I'm only concerned about how the graph would look like between x equals to 0 and 5, or one can say x is less than 5. So the term, if you look at mod of x minus y, would be equals to 2 plus mod of x minus 5. If I take this particular term on the right hand side. Now understand, in the interval 0 to 5, when x is between 0 and 5, the term mod of x minus 5 can be written as 5 minus x, because mod of x minus 5 need to be positive. So it will become mod of x minus y is equals to 2 plus 5 minus x, and this thing basically become equals to, one can say, a 7 minus x eventually. Now, if I say mod of x minus y is equals to 7 minus x, then x minus y can be plus or minus of that quantity. Because we know if mod of, let's say, a is equals to 5, then a could be a plus 5 or a minus 5. So one can say we have two cases. One is when x minus y is equals to 7 minus x, or x minus y is equals to minus 7 plus x. Let's take both this consideration. If I look at this particular scenario, one will get 2x minus y to be equals to a 7. It will be a straight line whose x-intercept, one can say, would be at 3.5, and the y-intercept would be equals to a negative 7. So we can say somewhere over here, this is a y-intercept, let me call 0, minus 7. Now, what about the value of, let's say, y for x equals to 5? If I put x equals to 5, the value of y will come out to be equals to a 3. So in this particular case, maybe somewhere over here, one can say we have a point called 5, 3. So in short, 2x minus y equal to 7 basically will be a straight line which was going to look like this. And please note, as I told you, I'm only concerned about the portion between x equals to 0 and x equals to 5. Over here, this will give me, one can say, x will get cancelled out and one get basically y to be equals to a 7. Now y equal to 7 is going to be a straight line parallel to the x-axis. So this is y equals to a 7. So this point, one can say, would be a 5, 7. This point one can say would be equals to this is going to be a 0,7 over here. And if I look at the area between the x equals to 0, x equals to 5 and the lines over here is giving me this particular quadrilateral if I'm calling it as A, B, C and D. Now understand this ABCD in this particular case happens to be a trapezium as BC and AD are parallel. Now can I know what is the length of BC? If you look at over here, they have the same x coordinate. So the length of BC become nothing but difference in the y coordinate. 7 minus 3 will give me nothing but equals to a 4 here. Then if I look at the length of AD, in that particular case, again the x coordinate are same. So the length of AD is nothing but the gap between the number 7 and minus 7, which is 14. So we got the length BC as 4, the length of AD as 14 and the length AB is nothing but 5, because in this particular case if you look at the point AB, the y coordinate are same. So length of AB is nothing but equals to 5, the gap between 5 and 0 which is 5. So now at this particular moment then AB is also one can say the height for this trapezium. So the area of the trapezium or the quadrilateral ABCD would be equals to half sum of the parallel side, one can say AD plus BC, times the height, which is nothing but AB over here. If you put the values, half of AD plus BC will become 14 plus 4, which is 18, times AB, which is equals to a 5, and this thing becomes half of the number 90, or this is 9 into 5 giving you a 45. So the required area in square units basically must be equals to a 45, and one can choose to enter 45 as the answer. But as you can see, it's a very difficult question and many of the students might not be able to understand what exactly need to be done and how the graph is going to look like. And they might also be concerned about how the graph might behave beyond x more than 5 or let's say x less than 0. But we have to only concern ourselves between x equal to 0 and 5 over here. In the next sum, it says that let both the series A1, A2, A3 and so on and B1, B2, B3 and so on happens to be in AP. So both the sequence given to you are in AP such that the common difference of both the series are prime number, a very, very important point. Suppose if I call D suffix A is the common difference of the first sequence and D suffix, let's say small b, being the common difference of the second sequence. So both DA and DB need to be prime number. Now they are saying A5 is equals to B9. So A5 is equals to B9. And they are saying A19 is equals to a B19. So understand one thing in this particular case, these two things are same. If I call this to be equation number 1 and equation number 2. Now, if you look at the difference between the 19th term of the first sequence and the 5th term of the first sequence, the gap basically happens to be 14. So this should be equals to 14 times of the common difference of the first sequence. What about over here? The difference between the 19th term of the second sequence and the 9th term of the second sequence is nothing but equals to, one can say, 10 times the common difference of the second sequence. So from here, one can find out that the ratio of DA and DB is 10 by 14, which will reduce to, one can say, 5:7. And now since they have told you the common difference need to be prime number, one can say DA need to be 5 and DB need to be equals to a 7. They have also told here that B2 is equals to a 0. And the task is to find out the value of over here A11. So one can look at A11, if you look at, can be termed as the 5th term plus, one can say, 6 times the common difference, 6 times of DA. Now how do you find out the 5th term? The 5th term, one can say, is equals to the 9th term of the second sequence, B9 plus this is 6 into 5, which is 30 right now. How do I find B9? Because if you look at, they have told you B2 is 0. So B9 I can write as B2 plus 7 times the common difference. B2 is 0. So this particular part, 7 times of DB will be nothing but equals to a 49. 0 plus 49 give you 49. So B9 becomes a 49 plus 6 into 5 is 30. So the required total become equals to a 79. So the 11th term of this sequence happens to be nothing but 79, and hence one can choose to mark option number 2 over here. Now once we found out the common difference of both the sequence, I can do something of this also. Since they have told you A5 is equals to B9, and for the first sequence we can say this is also A19 is equals to a B19. That simply means that the term A12 should be equals to nothing but B14 as well. So what we can do is we can find out the value of B14. So B14 as the value of B2 is given. So it will be B2 plus 12 times the common difference. Now since B2 is equals to 0, the term 12 into DB is nothing but equals to 84. So we found out the value of A12 to be equals to 84. So can I say A11 is what we are supposed to calculate should be equals to A12 minus the common difference of first sequence. So it must be 84 minus 5 giving you a 79. And hence one can mark option number 2 over here. In the next sum, it is given that if p square plus q square minus 29 is equals to 2pq minus 20, which is also equals to one can say 52 minus 2pq, then the difference between the maximum and the minimum possible value of p cube minus q cube will be how much? So first of all, let's see what can be done in this particular context. So if I suppose take the first one and the second one, and if I bring the term involving p and q on one side and the number on the other side, one will find out p square plus q square minus 2pq is equals to 29 minus 20 giving you a 9. And one will get p minus q whole square equals to a 9, and that will give you a p minus q to be equals to a plus minus 3. Now understand, to find out the value of p cube minus q cube, which is going to be equals to p minus q whole cube plus 3pq into p minus q. So we are supposed to know the value of p minus q and p into q. If I take the second term and the third term, so if I equate them and if I again bring the term involving p and q on one side, so one will get this 4pq is equals to 52 plus 20 giving you a 72. And hence the value of pq become equals to a 18. So as you can understand, as I told you, that the value of p cube minus q cube will be equals to p minus q whole cube plus 3pq into a p minus q. Now the value of p into q is constant, which is equals to a 18. So this particular part become p minus q whole cube plus 3 into pq will become 3 into 18, which is 54 times of p minus q. So as I told you, p minus q comes out to be a plus 3 or a minus 3. If I want this max value of p cube minus q cube, in that particular case we will take p minus q as 3. That will give you 3 cube plus 54 into 3. And in case I want the minimum value of p cube minus q cube, that would be equals to a minus 3 cube plus 54 into a negative 3. And this thing, if I simplify this, will become a minus 3 cube minus 54 into 3. And we want to take the difference between the maximum and the minimum. So if I do subtract over here, one can see this particular term, if you want to evaluate, will be a 27 plus one can say a 162, and this thing one can say will become equals to a 189. This thing will be minus 27 minus 162 comes out to be a negative 189, and the difference between 189 and minus 189 happens to be nothing but 2 times of 189, giving you a 378. And hence the required answer for this particular question would be option number 3 over here. Now please note that if someone have taken the first term and the third term, you will get possibly p square plus q square plus 2pq, and that will be equals to one can say 52 plus 29 giving you one can say 81. So one will get p plus q square to be equals to 81, and that will give you p plus q to be equals to a plus minus 9 over here. Please note that P plus Q doesn't decide on the value of PQ minus QQ, because that depends on P minus Q and P into Q. P into Q is unique, but the value of P minus Q can take two values and hence lead to maximum and minimum. And we got the answer to be equals to a 378. In the next sum, it is given that let AN and BN be two sequences such that AN is equals to 13 plus 6n minus 1 and Bn is equals to 15 plus 7 into n minus 1 for all natural numbers n. Then they are saying the largest three-digit integer that is common to both these sequences. If you represent, suppose the An, which is equals to 13 plus, this part becomes 6n minus 6. So An become equals to, one can say nothing but this is 6n plus a 7. Now if I look at Bn sequence, 7, 15 plus 7n minus 7, and this becomes 7n plus 8 over here. Now the sequence An and Bn are both going to be nothing but a sort of AP. The term 6n plus 7 for every value of n basically will keep on increasing by the value of 6. So one can say one such value would be, if I put n equals to 1, because they are saying for all natural numbers n equals to 1 will give me nothing but a 13, then a 19, then a 25, then a 31, 37, 43, and so on like this. What about this sequence for n equals to 1 will give me a 15, and this is going to be a AP with a common difference of 7, 15, 22, 29, 36, 43, and so on like this. We are supposed to find out the largest three-digit number that is common to both the sequence. First number which comes to your sequence happens to be nothing but 43. And since my first sequence goes in a increasing increase of 6, the second one is increasing by 7 in this particular case. So once I found out the first number is 43, the second common term should be after an interval of, one can say, a term which is a multiple of both 6 and 7, which are my common difference, 42. So one can say 85 is what you are also going to find in the both the sequences. So 43, 85, and then one can add 42 again, giving you a 127, and so on like this. So what is my target? Target is to find out the largest three-digit value over here. So 127 being the smallest three-digit number, my task is to find out the largest term, which is the three-digit number, 43, 85, 127, and so on like this. This is also an AP with a common difference of, one can say, a 42. So the term T of n must be less than 1000. The general term in this particular case is 43 plus 42 into n minus 1 less than 1000. So one gets a 43 plus 42n minus 42 less than 1000. So 42n plus 1 should be less than 1000. And one in this particular case, one need to find out that what is that value of n which I can take over here. So definitely if I put n equals to 10, 42 into 10 becomes a 420. If I put n equals to 20, you get 42 into 20 giving you 840. We still have a buffer of, one can say, another 160. So 42 into 4 will go beyond the number 160. So the value of n I can take another will be nothing but n as 23. So if you look at the term here, comes out to be 42n plus 1. And if I put the value of n as 23, so 42 into 23 plus 1, 42 into 3, one can say, happens to be equals to a 126, 6 carry 12. 42 into 2 happens to be a 84, 84 plus 12 becomes a 966, plus 1 becomes a 967. So the largest three-digit number which happens to be common to both the sequence happens to be 967, and hence the answer for this particular question would be a 967 over here. Now if you look at over here, the sequence in the AN happens to be 6n plus 7, and this, if you look at, if you divide this by 6, it is nothing but of the form 6n plus 1 only, or maybe one can say 6x plus 1. Over here also, if you divide the term 7n plus 8 by 7, again you get nothing but remainder of 1 over here. So if you have basically the sequence of an in a way 6kx plus 1, sequence bn in the form of 7y plus 1, both having the same remainder, then we can use the concept of LCM scenarios. So my common term in this particular case is going to be nothing but LCM of 7 and 6 giving you a 42 into something plus a 1. And you want to look for the value of k, which is going to make the term 42k plus 1 to be below the number 1000 mark. And we have seen that it should be k equals to a 23. That will give the term 42k plus 1 as 966 plus 1. And hence the required answer for this particular question become a 967.